Okay, let's unpack this. We are diving deep into a topic that usually makes IT budgets, well, groan.
Right.
Enterprise virtualization.
Right.
For years, if you needed the absolute best performance, stability, and security for your virtual machines, you had to write these enormous checks to proprietary vendors.
I'll just accept that vendor lock-in was, a fact of life, an unpleasant one.
But our mission today is to explore a collaboration that's really challenging that entire model. We're focused on this integrated solution from Nexsan and Vates.
Right, so you have Nexsan providing the enterprise-grade storage backbone with their Unity platform.
And then Vates, bringing the power of open source virtualization with the XCP-ng, hypervisor, and Xen Orchestra management stack.
And this isn't just some white paper concept. It's a fully validated, ready-to-go architecture.
That's a key point.
The market has been starved for a solution that provides true enterprise security, especially against modern threats like ransomware, without the crushing complexity and, the cost of proprietary licensing.
Virtualization environments are now ground zero for these attacks, aren't they?
They absolutely are. So security is non-negotiable, but if that security throttles your performance, organizations just won't adopt it. It's a non-starter.
Exactly. So what we want to show you today is how this integrated stack delivers a revolutionary approach to security, 5 distinct layers, in fact. And it does this while delivering speed that actually surpasses traditional platforms, all while letting you finally escape those restrictive commercial licensing agreements. We're looking for that trifecta: security, speed, and savings.
Let's get into it.
To understand how they did this, we have to look at the architectural foundation. So let's start with the storage component, Nexsan Unity.
Okay.
The source material really emphasizes its unified architecture. It supports file, block, and S3 object protocols simultaneously on a single platform. We talk about silos a lot in IT. Why is eliminating those such a big deal, practically speaking?
It solves complexity. And complexity translates directly into cost and risk. Well, think about it. When you have dedicated storage arrays for file data, separate SANs for block data, like your VM disks,
Right.
and then maybe separate boxes for object storage and backups, you suddenly have 3 different management interfaces, 3 different patching cycles, and you need 3 different skill sets on your team.
It's a headache.
It is. Unity brings all of that into one unified management pane. But the real insight here is how it treats the data. It's not just a collection of drives. It's a highly intelligent, tiered storage environment.
Okay, so it's using a mix of flash and regular drives.
Exactly. High-speed flash and capacity-optimized drives. But what makes this so relevant for your VMs are the advanced caching algorithms that are working behind the scenes.
So they're automatic.
Completely. They automatically detect which data blocks are being accessed most frequently, say, the core files of a database VM, and they promote them instantly to that fastest flash tier. This intelligent placement ensures your most sensitive workloads always get the speed they require.
All without manual intervention.
Invisibly. That invisibility to the hypervisor is key. The VM gets the performance it needs without the IT team having to constantly tweak storage policies.
All right, let's pivot to the virtualization layer. Vates XCP-ng. When people hear open source, they sometimes worry about, feature parity or maturity.
That's a fair concern, but XCP-ng addresses it head-on. It's built on the proven, battle-tested Xen architecture. This isn't some beta product. It has a serious pedigree.
So it's stable.
Very. And because it's open source, it avoids those proprietary license costs, but it retains full feature parity with any high-end enterprise solution you might be familiar with.
So we're talking things like live migration and high availability.
We're talking instant features like live migration between hosts, high availability clustering, distributed virtual switching, the works.
So you get a fully functional hypervisor that doesn't require a massive license fee just to unlock basic HA functionality.
Precisely.
But the real game here is the integration, right? I mean, anyone can combine an open source hypervisor with some random storage array.
Exactly. The power isn't in the parts. It's in the validated integration. Nexsan and Vates didn't just tell customers, hey, go try this.
They actually tested it.
They meticulously tested the entire stack. This synergy eliminates that uncertainty IT teams always face when they're combining technologies from separate vendors.
No more finger pointing when something goes wrong.
None. The solution is confirmed, compatible across all major connectivity options, iSCSI, Fibre Channel, and NFS. This validated approach means performance and, critically, support is guaranteed.
Okay, so this validated architecture is the bedrock.
It is, and it's so crucial for security. We are no longer living in a time where a firewall at the edge is enough. The core thesis here is multi-layered, ground-up security designed specifically for modern threats, particularly ransomware that loves to target your backups.
Let's talk about those layers because IT teams need more than just a bulleted list. They need a roadmap. 5 distinct layers of protection here. Where do we start?
You start with the ultimate last resort, that's layer 1, hardware-level immutable snapshots.
Okay, immutable, meaning it can't be changed.
Cannot be modified or deleted. Traditional backups often fail during a ransomware attack because the malware finds the backup server and just encrypts or deletes the recovery points.
Right, they go for the backups first.
Always. Immutable snapshots are fundamentally different because they cannot be touched, even by an administrator, for a predefined period. And crucially, Nexsan Unity enforces this immutability at the storage hardware level.
So wait, if a virtual machine gets hit and the ransomware tries to send a command down to the storage to delete the snapshots?
The hardware itself just rejects that command. It doesn't matter what the operating system is telling it to do. It's a digital safe deposit box where the safe itself controls the lock.
And Vates automates the creation of those snapshots.
Right. The VMS integrates with this capability by automating the orchestration, making sure consistent, frequent snapshots are being taken and managed, ready for recovery.
That addresses data recovery. But what about stopping the compromise in the first place? Let's move up the stack to access control.
That's layer 2. Multi-level authentication and RBAC. Security has to be enforced across the whole solution, not just one part.
Right.
So Nexsan Unity imposes rigorous authentication for storage management, while the Vates components rely heavily on role-based access controls, or RBAC. This is all about the principle of least privilege.
So people only get the access they absolutely need for their job.
Nothing more. And what's fascinating is that this isn't some proprietary identity system. It integrates smoothly with your existing enterprise systems like LDAP and Active Directory, and it fully supports modern multi-factor authentication.
And I'm guessing there's an audit trail?
Oh, a very detailed one. Every single action is tracked via audit logging that you can export directly to your SOM system, which is vital for compliance and monitoring.
Non-negotiable in some industries.
Yep.
Okay, layer 3. This is about data at rest and in motion.
Layer 3, inherent encryption. Encryption is embedded throughout the entire data lifecycle. For data at rest, the files just sitting on the disk Nexsan Unity offers hardware-accelerated encryption.
Meaning it doesn't slow things down.
Exactly. It uses dedicated encryption processors so you get strong AES-256 protection with virtually no performance penalty, which is often the big trade-off in software-based encryption.
And what about data that's moving?
For data in transit, Vates components secure all the management traffic and VM migration data using TLS encryption. And to follow best practices, the whole setup can integrate with Enterprise Key Management Systems, or EKMS.
So your keys are stored securely, not just sitting on the same box.
Exactly right.
Okay, we've covered physical separation, identity control. Now let's talk network philosophy. Zero trust. Everyone defines it differently. How does the solution actually execute it?
That's a great question. This is layer 4, execution of zero trust architecture. Zero trust is all about continuous verification, treating every connection as potentially hostile.
Assume breach.
Assume breach, always. In this environment, the solution applies that philosophy structurally. Nexsan Unity uses microsegmentation to logically isolate storage resources. Think of it like putting concrete internal firewalls between different storage volumes.
So if one area gets compromised, the breach can't move sideways.
It prevents that lateral movement. And the XCP-ng hypervisor does the same thing, enforcing strong isolation between the virtual machines themselves. If a hacker breaches VMA, the architecture makes it significantly harder for them to pivot or jump to VMB.
And that's all part of that validated integration we talked about.
It ensures these principles are applied consistently across both storage and compute.
And finally, the ultimate safeguard, the air gap. We hear that term a lot, but it's often misused. What is layer 5, and how is it truly air-gapped?
Layer 5, true air-gapped backup options. This is maximum protection. It involves physical separation using dedicated Nexsan air-gap appliances. These systems are totally disconnected from the production network.
So no physical or logical link at all?
None, except during very short scheduled backup windows, which might only be a few minutes long.
So if the primary network is completely compromised, an attacker has a window of maybe 5 minutes a day to even try to access the recovery system.
Exactly. It shrinks the attack surface almost to zero. It guarantees your recovery data remains pristine and inaccessible to any network-borne threat. It's the ultimate physical insurance policy.
5 layers. That is an impressive defense strategy. But here's the challenge every IT manager is thinking. That sounds like an enormous security blanket.
Mm.
And every time we introduce this much security, we slow the system down. Did they actually pull this off without crippling the speed?
It's the critical question. And the source material shows that the optimized architecture, the lightweight XCP-ng hypervisor talking directly to the high-performance Unity storage stack, actually boosts speed.
Boosts it.
Yes, because there's less overhead in the communication path. And we have concrete benchmark numbers to prove it.
Okay, let's hear them.
First, look at agility. VM provisioning speed.
Right.
Compared to traditional proprietary platforms, provisioning times are cut by up to 65%.
Wow, 65%.
This is the result of XCP-ng's efficient architecture, being able to leverage Unity's instant VM cloning and optimize metadata handling. Faster provisioning means faster disaster recovery and faster response to business needs.
That is a massive operational win. But what about under heavy load? I'm thinking of really I/O demanding environments like financial databases.
For those workloads, like SQL Server and Oracle, we see remarkable I/O throughput, increases performance improvements of 30 to 40% over traditional platforms.
And why is that?
It's attributed directly to Unity's intelligent caching and hardware acceleration. It minimizes I/O latency by ensuring database reads and writes skip all those unnecessary software layers.
So for those really critical applications like trading platforms where latency is everything.
The solution maintains constant sub-millisecond latency, even under sustained, intense load. This reliable performance means organizations can safely virtualize applications that historically required dedicated, expensive physical hardware.
Just because they were afraid of latency spikes.
Exactly. That's a huge shift in infrastructure design philosophy.
Sub-millisecond latency under load. That is the structural proof that security and performance don't have to be mutually exclusive.
They don't.
Okay, let's pivot to the financial freedom, which is often the primary driver for a shift like this. Escaping vendor control.
It's the strategic advantage that lasts for years. The open-source Vates VMS stack just fundamentally transforms the economics of virtualization. Organizations switching from proprietary solutions like VMware or Hyper-V report a reduction in licensing costs of a staggering 50 to 70%.
Wait, 50 to 70%, that's immediate and dramatic. But what's the catch? Is the support model as good?
That is the right question to ask. The savings come from eliminating those restrictive per-socket or per-core fees, and you replace them with optional, fully integrated enterprise support subscriptions from Vates.
And because it's validated, the support teams work together.
They coordinate. You avoid that classic blame game where hardware and software vendors point fingers at each other.
That simplifies life for the IT department immensely. But let's look at the long view. Total cost of ownership, TCO, over 5 years.
The TCO reduction typically exceeds 45% over a 5-year period. And this goes way beyond just license fees. It includes reduced administrative overhead because you're not spending time preparing for surprise license audits.
A pain point for many.
And on top of that, the hardware efficiency of this integrated system, the ability to get higher VM density on your existing servers because XCP-ng is so lightweight, means you extend your hardware life cycles. You delay expensive capital expenditures.
And the source has a great real-world example of this.
Absolutely. A mid-market financial services firm managing around 200 virtual machines. They documented 2 key outcomes. First, they reduced their virtualization licensing costs by over 60%.
Over 60%.
And second, while doing that, they improved performance for their core database workloads by 35 to 45%.
So they saved a ton of money and got better performance.
It's the living proof. You can achieve massive cost savings while simultaneously improving the quality of your infrastructure.
And strategically, by embracing open architecture, businesses gain a level of freedom they just haven't had. You maintain bargaining power. You're not stuck with one vendor's pricing or roadmap.
That freedom is a genuine competitive advantage. For organizations looking to adopt this, implementation is often the biggest hurdle, psychologically.
Migrating from a platform you've used for a decade.
Exactly. But the Vates VMS stack has built-in tools designed to ease the migration from platforms like VMware, Hyper-V, and KVM. They even support live migration to minimize downtime.
And as businesses grow, what about scalability? How does this architecture handle growth?
It's built for it. Nexsan Unity storage scales from tens of terabytes to several petabytes, and XCP-ng can handle large cluster implementations with thousands of VMs. The key is that the performance profile, that sub-millisecond latency, remains consistent as you expand.
And I imagine the unified support model scales just as well.
It does. Both Nexsan and Vates offer 24/7 enterprise-level professional support. For anyone managing critical infrastructure, Knowing those two support teams are already coordinated to solve problems in the combined environment is a massive practical benefit. It reduces stress and shortens resolution times.
So this deep dive shows you can, in fact, have it all. High-performance infrastructure, ironclad security with those 5 layers, and significant cost control, up to 70% license reduction, all at the same time.
It's a compelling case for rethinking your entire virtualization strategy.
Moving away from systems built on legacy licensing toward a modern, validated open architecture.
Right. And the shift toward open architecture, validated integration, and security transparency, it fundamentally changes who controls the future of your critical infrastructure.
You're taking back control.
You are. It is a necessary movement away from relying solely on vendor assurances toward relying on transparent, verified security validation. And this raises an important question for you, the listener. If you could save over 50% on licensing costs and gain superior performance and 5 layers of defense, what opportunities does that level of control and financial freedom unlock for your specific business objectives?